Good afternoon. Okay, so it looks like we have some not reverberation, but we have a microphone hooked up. Is it easier to hear me? Okay. First, a little bit of housekeeping. I updated homework 2, the PDF file. I did not change the functionality of the assignment. I didn't change what you're supposed to do. There were just a couple of details that I needed to clarify. First was that there was a typo. In homework 2, it says your sentinel value should be -1234. Should be -12345 to match homework 1. What else? I sent out an email with a couple of frequently asked questions, and then I updated the hw2.pdf file on CCLE as well. Okay, so the other thing is you don't have to make operator equals a friend function if you can use another member function to get the desired functionality. So a student emailed me and said they figured out a way to not require the use of friendship for operators equals, and I said, yeah, that's fine. You don't have to make it a friend if you don't want to. But the homework assignment makes it sound like you have to make it a friend function. Okay, so I modified that to say, you can if you want, you don't have to. Okay, so if you already wrote homework 2 and it works, the only thing is that sentinel value of -12345 needs to be this match homework 1. Okay. So yes, you can get rid of all functions that you don't use anymore if you want. You can leave them in if you want as well. Okay? So I think the transform function we're not going to use for homework 3. But yeah, you can keep them in if you want. You can take them out if you want. Yeah. Okay. Okay, so last time we left off, and I kind of teased you a little bit at the end, and I said, okay, you know how with vector you can do v of 0, v of 1, v of 2? That's just an operator. The object v is just invoking an operator, open, close, square brackets. And I said we could do that with our fraction object as well. So for example, I said we can write code to access, for example, the numerator if we wanted to. We probably wouldn't want to, but we could. Here's how. So we go to our fraction class, and look how nice and clean our fraction class is. Okay? This is the advantage to declaring and then defining later. Okay? The advantage is, I mean, look at how everything looks really nice and clean. If we want to know the different ways that we've defined to create a fraction object, we know that there's 3 default 1 parameter and 2 parameters. If we want to know which operators we have defined, we have a simple list right here. So arithmetic operators. You know, we know here we've implemented the increment operators, and then here we have a few comparisons. Okay, and this one will print the fraction. Okay, so it looks really clean, and I think it's very readable in this format. Now, if we go below main, now we get some just lots of ugly stuff. Okay, we have all the code that does things. It's code that performs operations on the variables. There's comments everywhere. It's kind of difficult to just glance at it and get a nice view of what it's actually doing. Okay, it's readable. It's perfectly decipherable, but it's not quite so quick to understand or to access. Okay, so let's now show how to overload the square bracket operator. So these square brackets are in fact an operator. So it's a member operator. So we write int for the return type. Now the name of this operator is operator open close brackets. That's the name of the operator. And now this operator is somewhat special. You need to give it an argument. Not only that, but you need to give it exactly one argument. Okay? So we're going to denote this by, well, not denote it, but you tell it, say, all right, I'm going to overload you with a string variable. Okay, let's do a const string reference. let's just say value. Okay, so now I can make a of quote numerator end quote something. I can have that do something and compile and run. Okay, now I can also overload this for say an int. And say its value as well. Actually, I don't even need to specify the data type, the name, so let's not. Okay, so let's just say we're going to input some string, and we're going to input some int. Okay, now let's define these. And again, we're trying to make these two bits of code work. And the idea here is, let's have both of these return the value of the numerator. Okay, so how do we make that work? Go down to the bottom here. All right, here we go. So first we'll start with this const string reference version. Okay, there's value. Now, okay, there's also and this is a reminder. This is not just some operator open close. This is a fraction operator open close square brackets. Okay, it belongs to the fraction class. It is a member function. Now we can do something. You would never do this in production code because why would you have an operator like this where you input like literally the string numerator? Maybe you'll come up with something, but it's not a very natural operator to define for a fraction type. Okay? Maybe for a vector type, like v of 0, v of 1, etc. So what we're doing right now is really just an example. We've really developed this fraction class to a really nice numerical way of working with it. And now I want to just show how the remaining set of operators can be utilized in this same context, but we wouldn't do it for this context. We'll show how to do it for a different context. So if value equals, let's say, numerator, return numerator. How's that? Seem reasonable? Okay. Else if value equals denominator, return denominator. Else return 0. Okay, so first, let's. Oh, looks like I commented out. Let me get rid of this. I did post this this source code on CCLE before I came here. So, okay, fraction a of 1/2. Start with that. Okay, now let's recompile this. Let's get rid of everything below. Okay, now we're starting out fresh. Okay. So this is a noble effort, which is, okay, let me try and compare value to a value. Okay, but what happened? Can I do that? Have you ever tried to do that? Let me try something. Oh, well, that was unexpected. Hang on. Okay, let me get rid of this const for a second. Oh, okay. If I get rid of const there, I got to get rid of it up here. Here we go. Oh. Well, I guess I never tried to compare two strings before. Like this. Yeah, what is it? Value dot equal, what is it? Yeah, that's not C++, or that's not the string std string. How did I do this before? Oh, weird. Okay, let's scratch this one for now. I guess we could. Oh, okay, here's an interesting thing you can do. Operator equals equals const string reference. Now, how would you want to compare two strings? You would want to check, so let's see, for size t I equals 0, I less than side dot size I plus plus. Let's just do a quick one where we assume they have the same size. Let's bool flag. Well, okay. We check if left-hand side of I does not equal right-hand side of I, return 0. Otherwise, if we make it through the entire vector, return 1. Okay. Nice. Okay. Okay. Then we do a string here. Now this should work. No. Oh, because I didn't define the int version. Let me hold off on the int version for a second. Okay. Finally. All right. So the okay. What did I do and why did I do it and why is this definitely a bad example to use? Okay. Here's what happened. I wanted to compare if this string had the same set of characters as that string. Well, the standard string library does not let you do that using equals equals. Okay? There are good reasons for this. Yeah, question.
Did you include string at the top? Yeah.
Maybe that's it. Because it. Yeah. Ah. I thought I was. I didn't. You know. Let me see. I thought you could do this. Let's see if I get rid of it. Nice. Okay, that was it. Yeah, I did what many of you will actually do, which is not number includes string. Okay, that's why it didn't work. Ah, okay, but even though it didn't work, because I forgot to number include string, you see what I was able to do, though? I was still able to make it compile. Why? I overloaded an operator. Okay? I mean, as long as the operator is acting on a non-built-in data type, you can overload it. Okay? So that's the moral of the story is, in this case, we didn't need to do it. But in cases where you try to write some code and you say, gee, it'd be really nice if I could write code that looks like this. But there's no operator defined, what can you do? Make one. Okay? That's the idea. The idea is your code should be readable. And if you have to define new operators to do that, that seem reasonable and make sense, then you have absolutely the tools that you need to do that. Okay? So this is a good demonstration of if you don't have it, you can make it. But in this case, it's better to use the one that's built in. So let me just write, not necessary once you properly include string. Okay. Good, good, good. So that allows us to write this. Now let's run this, and I get the 1 that I wanted. Okay? So let me go back to main. So I type in numerator, I type in denominator, and there's my 2. Okay? If I type in anything else, I get a 0. Okay? So why would you do this? You wouldn't do it for a fraction. Okay? For a fraction object, this is a little silly. Okay? But you might do this for another class object. The other thing, too, is why did I have to write... See, do I still have to do this? Yeah. So even though I've included the string library, do you guys know why I still have to write string around this quotations? This is something a lot of students, even from 10C, didn't fully internalize yet. So I know this can be an issue. So the key is obviously here. And what does the error say? So the IntelliSense says no operator, open close brackets, matches these operands. It's a bit easier to read the IntelliSense errors usually. Operand types are fraction of const char 12. Did we mean, wait, what's a const char 12? Yeah, it's a character array. Did we intend to make a character array? No, but we did. Okay, so by default, when you use quotes, what does that do? Creates a const char array. Okay? Now, can you initialize a string using a const char array? Yes. Okay, so what I'm doing is I'm taking a const char array, and what would normally take 2 steps, so rather than writing that line, I should really have to write, string name equals denominator. That'll work, right? You guys all know this will work. Okay? And then writing cout a of name. Okay? Rather than doing that, I'm combining it. I'm saying a of, now, construct a string object using the string, or using the const char array denominator, and then use that string object as the input into the operator open close square bracket. Okay? This calls a constructor, and as a matter of fact, it creates a string object with no name. Okay. It's called an unnamed variable. The object exists, very much like when you do fraction f postfix++. That object does exist, but you have no way of, there's no name associated with it. Okay? So this does, in fact, create a string object using a constructor that takes this as an input parameter, a const char array. It returns an actual string object. You don't have a name for it, but it exists in memory, and that object is what is used for the square bracket function. Question? The question is, does that mean it's in the heap? Don't worry about it. It's actually on the stack, but it doesn't matter. You're creating the variable on the stack. It's a unnamed variable on the stack, which is fine. An unnamed variable on a stack is actually a very nice unnamed variable. There are a lot of extra things you can do with an unnamed stack variable. 10C. Meet me in 10C to finish that conversation. Okay, so yeah, basically we need to input a string, and putting a bunch of characters inside of quotations does not, by default even, give you a string. It gives you a const char array. So that's why you have to write this string in front of it. Okay? Okay. So that's the square bracket. Now, the thing about, let's do the int one. So let's just say that for the int one, okay, here's the int one. If value equals 0, return numerator. Else if value equals 1, return denominator. Denominate. Okay, it'll be easier if I just correctly write fraction, colon, colon, and then it'll denominate. Come on, where's my autocomplete? There we go. Denominator, else, say return, what the heck? Return negative 1, 2, 3, 4, 5. 0 is too unsafe of a value. So is negative 1, 2, 3, 4, 5, but in lieu of a better alternative, we'll do that for now. Okay, so here's main. Now writing something like cout a of 0, a of 1, something like this, should absolutely work. And there we go. Okay? And if I wanted to see out a of that, it should give me the sentinel value that I gave it. Okay. Now, you can only ever pass in only accepts one argument. Okay? If you want to write, for example, let's say you want to write a of 3, 4. I don't know, what would that do for a fraction? Who knows? But if you wanted to write it like a 3, 4 monkey 3.14, okay? You can define it to do something. Okay? So let's define it to do something. So what is this function? This is a function. This is using the parentheses operator. So it makes the object act like what? Like a function. Okay? So now we can overload as many parameters as we want using the, not square brackets, but the operator open close parentheses. Okay? Can have 0, 1, 2, etc. arguments. So for example, int operator, and this is how you would write it for, say, 2 arguments. Int, int. Or you can do int operator like we did. Int, string, say const string reference, double. What's that? Yeah, we did a character array, but you should stay away from character arrays. Just work with strings. Trust me on this one. Unless you really need performance, character arrays are not how you want your mind to be thinking while coding. That's why there's a string library, and it's very popular. When I first started coding in C++, I did not have the string library. I really wished I had a string library. I was forced to work with pointers. You remember learning about pointers in 10a? Remember how much fun that was? Imagine learning that in week 2. Okay? Imagine instead of learning how strings work, you had to go straight to how pointers and arrays work. Appreciate the string. Okay? Yeah. I appreciate the string. Yeah. So always go to string unless you literally can't. Okay? Or you need to eke out every last flop of performance. It's better to write like string in front of the parentheses than to try and mess with car arrays or arrays in general. That's my opinion, and I'm sticking to it. Okay, I can also create a function that has no parameters. It looks like that. Looks kind of weird, doesn't it? Yeah. Okay, let's see what this does. Let's define these to do different things. Here we go. And here's how we would define these functions. Okay, so let's just hold off. Let's do this one first because we had a really weird thing for it. Okay, fraction, colon, colon. All right, so it takes an int, say a, int b, const string message, double d, and then we'll see out a, b, and then we'll write if message equals monkey. We'll see out no monkey business here. No monkey business here. There we go. That's better. All right. And then see out d. Must return a value. Okay, we'll return d. I can have it return whatever type of value I want. Okay. The int was just random. Oh, d. Oh, there's my. Oh, what does my warning tell me? Yeah. Let's do some. I mean, again, this is not, let's just statically cast it to an int. So we call this function, and it returns the value of the double floored. Okay. Now, in main. Oops. Here's in main. 3 for monkey. That should print out, okay, here's a bunch of stuff. So first thing, it goes into and it calls the a with parentheses function, and it prints out 3 over 4. So the first one and the second one. 3 and the 4. It is equal to monkey, so it prints out no monkey business here. Prints out the value of the double, and then it returns the value 3, because that's the casting of 3.14 to an int. And then that int, that 3, gets returned here, and that's what eventually gets coutted. Okay? So the parentheses operator basically tells you you can treat your object like a function. Okay? That's what's kind of cool about it. Okay? So all objects have the ability to be called like a function. You just get to define what behavior it does. Okay? So for example, here's something we might want to do. We might want to overload this parentheses operator with no parameters to maybe reinitialize the fraction. So this is fraction. Maybe after calling this, we want numerator to equal 0, denominator equals 1. And let's make it a void. Okay. Let's go back up to, okay, go back up to the top. And we replace it with void here. Okay, and then down in main, we can do a.print. We can do a open close parentheses, a.print. And we'll see it should reset itself. Yep, okay, let me put in some return carriages. Okay, so it resets itself. All right, so this is pretty much all of the operators we're going to be overloading in this class. Okay? Oh, wait, no, that's not true. In this first section. Okay? We're going to overload other operators, but we're going to do it along the way. So we're next going to cover a topic called polymorphism. And that's going to allow us to, oh man, isn't it kind of annoying writing a.print everywhere? Wouldn't it be nice if we could just cout a? You can do that. But we have to know what polymorphism is first. Okay? So that's the idea. The idea is I wanted to start operator overloading first so you get an idea of what's possible, and then we're going to learn more technical information in order to figure out exactly why these other operators will work the way they should. Okay? So I think that's all of the operators I have defined for your homework 3. I don't remember. I'm pretty sure. Oh, no. There's two more operators that I can define. Okay. Let me show you 2 more types. So first is for comparison operators. Okay? So with these ones, once you've defined less than and equal, you can define all of the other comparison operators in terms of these 2 functions. Okay? And that's the idea. So let's do that down below. Okay? So this non-member operator not equal, that was defined in terms of equal, just the opposite. Okay, let's think about what are the other ways of comparing 2 fractions. Well, we have less than, equal, and not equal. What's another operator that we could apply? Comparison? Less than or equal, right? That's different than a strict less than. What's another one? Greater than or equal. And then what's the other one? Greater than, right? Okay. So how do we define these? Are there any others? Am I missing some? I think that's it, right? Okay. Now, let's define these. Let's seek out its brother. There we go. There's its brother. We'll define them together. And again, remember, I should be including comments in every code that I write. All right. Let's tackle the greater than or equal to first, because this is an easy one. Now, I'm going to define this function in terms of strictly less than, equal, or I could also use, let's just do strictly less than or equal. Okay? how can I define greater than or equal to? Yeah, right? If something is not strictly less than, then the opposite of strictly less is greater than or equal to. Okay, so that's the easy one. So this is the one where we say, okay, return not left-hand side less than right-hand side. How easy was that? Okay, now how do you do the other ones? How would you do greater than? Well, let's start with less than or equal to. What would be, how would we define less than or equal to? Using just less than and equal equal. Yeah, right? So if A is less than or equal to B, then A is less than B, or A is equal to B. Okay, so again, you just sound it out, and you just say it the way that you would want to think it, and the code almost writes itself. Okay, we return left-hand side less than right-hand side, or what? Yeah, or left-hand side is equal right-hand side. And again, just put them in parentheses just in case there's any confusion as to the order of the operations or precedence. It doesn't cost you anything, and it makes a lot more sense. Okay, now just think about that one for greater than. Okay, it's not a challenging exercise, but just one that I want you to think about, try to do for yourself, and convince yourself you get it. Okay. And again, don't use anything other than less than or equal equal. Okay, that's the key. Don't even call the ones that we've made it down here. Go back always to the fundamental ones that we've written. Okay, that's the first one. Now here's another cool thing. Okay. What's something else we would like to be able to do to a fraction numerically? Okay, that's an open-ended question. Is there another representation for a fraction we might want to quickly access? Conversion to a decimal, right? That's the one thing you do with fractions, right? You work with them as an int over an int, but then at some point, typically you say, well, 1,028 divided by 2,867. Like, what is that? And we want to see like a decimal version of it. Okay? So you can actually, you can overload the conversion operators. Okay? So let's see how we would do that. So this is where it's a little bit it's a little cool. Watch this. Operator, let's say double. Now, should there be any parameters with this? No, right? Because we're just taking an object and we're just going to convert it. So there shouldn't, even in principle, be any parameters. Okay? Now, what should the return type be? Double. But it's already in there. So, okay, this is the weird, this is why the conversion operators are the kind of the weird operators. So let's go down below. And let's define it. So this is a fraction operator, double. And we're going to return static cast double numerator divided by denominator. That's this one here. Let's just turn true. That's really bad, but for now. Yeah, for now, just return true. Okay. Nope, further below. Okay. Now, what's kind of weird about this is you have two things. You have a bunch of things going on here. So first, did I explicitly mention the return type? No, but why wouldn't I need to? Because it's in the name of the operator itself. Okay, so it's redundant. All right, this is an operator space data type. Okay? Presumably that's what we're going to, if we're converting it to double, chances are we're going to return what data type? A double. Okay, so that's redundant. Second, there's a space between operator and double. Okay? You definitely need that there. All right? And then third is you just return the appropriate data type. Here, all I needed to do was statically cast the numerator to a double and then divide it by denominator. You don't actually need to cast both of them to doubles. As long as one of them is double, it'll do the double arithmetic and return a double. Okay? Now, here's something that's kind of cool. Now, because of this, if I go to main, this should work. Yeah. Now I can see out A. Why do you think I can see out A? Because it'll convert A to a double, and then there's no problem see outing doubles. Okay, so that's why you're allowed to do this. Now, it's not going to let me quite yet. We'll show how to do it, but right now I can't print out the 1 divided by 2. I can't tell it to do it quite yet. But what I can do is say, all right, well, convert it to a double, and then print out the value. So let's do that twice. Okay, so it should, the value of A is 1/2, prints out 0.5. Then we reset it to 0 over 1, and the value prints out as 0. Okay, so we've managed to, all right, if you wanted to see out a fraction object as a decimal, you can do it. Okay, not a big deal. Okay, so that's the double. We can also do something really weird too, which is the following. I think this, will this work? We should be able to return a string. Now, what string might we want to return? Let's see. Will this work? I think this will work. Let's give it the string consisting of, well, let's just say, now there's a way to convert an int to a string, but we'll learn about that a little bit later. So let me just write conversion to a string. Okay, so now we can convert it to a string. Okay, so let's see what happens. Let's go back to main. And let's try and write string message equals A. Works just fine. Let's see out message. And there's our message. Okay? So we can convert one object to another object or to another variable type. Okay? And we can specify exactly how that conversion is going to take place. Question?
When did you convert A into a double? If you have to put that in main.
Did I convert A to a double? Wait. Okay. Say that one more time.
When did you convert A to a double?
When did I convert A to a double? I didn't do it explicitly. The compiler did it automatically. Let me do it explicitly to show you where. So here, this is what's called an implicit conversion to double type. Okay? Here it calls the operator double. Here it pretty much, I don't know how you call this. I don't think you can do a.operator double. I don't know how that would work. Calls the operator double function on A, returns the value as a double. Okay? Another way to do this is you can write, say, double AA equals. You can do that. You could write static cast double. Okay? Either one of those these will explicitly convert A to a double value. by calling the operator double function. But what happens here is, here at the top line, that one with the cout, it says, do I have a function defined for a fraction object? The answer is no. The second step is, can I convert a into an object for which I have a version of the function defined? And the answer is yes. I can convert a to a double, and then I can cout that double value. That's a lot of implicit steps the compiler does for you. Okay? Now, the more things that happen automatically, usually the worse off it is. The reason is because everything's all fine and dandy until what happens? Compiler error. Then, if you don't understand why it's making the error, you have no idea what's going on. So it's implicitly converting the A to a data type automatically without your consent, without you basically telling it, I explicitly want you to convert this value to double. It's saying, I have the ability to convert this to a type that I can use for the cout function, or for the cout. Does that make sense?
What if you had two conversions, like two different ones? They had a double.
Yeah, so if I have two right now, so I actually wasn't sure what was going to happen because I have a conversion to a double and a conversion to a string. Either one of those can be couted. It went with the double conversion. It might just be the order in which they're defined. I'm not actually sure how it made that choice. That's a very good question. In general, you don't define these conversion operators. In general, you usually don't define conversion operators. For fraction, you'd probably only want to define the double conversion, and that's pretty much it. So let me see if I can switch the order. So the question is it because the double is a primitive type, and so maybe it has more precedence? That's a good question I don't know the answer to. That's a reasonable answer, which is fundamental types get precedence over object types. There's probably an answer to that in the standard, the C++ standard. I don't know it off the top of my head. The real answer, though, is don't define this operator. Only for demonstration purposes. Okay? So that's the real answer. The real answer is, okay, does converting a fraction to a double make sense? Yeah. Does converting it to an int make sense? Well, you could probably just pick double, right? And if you can convert from a fraction to a double, then you can do what? Yeah, this is my gesture for double to int. Okay? So as long as there's a path, as long as there exists a path to get to that data type, the compiler will find it. Okay? Okay, that's that. I think I got all the operators that we need for the homework. Okay, let me then give you a preview of what we're going to cover next time. Well, we have 5 minutes left, so I'm going to start it now. Pick 10b lecture notes. Polymorphism. Okay, so wait a minute. Maybe not polymorphism. Maybe I need to start earlier, actually. Class inheritance. There it is. Okay, here it is. Okay. Class inheritance. Now, did anybody learn about inheritance in 10a? Okay, so maybe one or two, but for the most part, this is new. Okay, so forget about that. All right, we're going to start out with my favorite class. It's called Point2D. God, I love this class. Okay, I use it in every class I teach. It's a simple class. It just consists of an x value and a y value, and then it's the private member variables, and then you can do stuff with it. Okay? But it's one of the most basic type of class objects. It's a collection of variables, two doubles, and then you do some operations on them. Okay? So you have a bunch of points, 1, 2, 4, minus 5, minus 7, 2. You just store them as, two doubles, basically. Okay? There's double x, there's double y, and have some constructors, you have some member functions, things like that. Okay, now, that's 10a. That's all fine and dandy. Okay, now, let's say, just like with our fraction class, right? Did we spend quite a bit of time with our fraction class? Yeah. Do we like our fraction class? Yeah, I do. Okay. But the point is that I understand how the fraction class works. I understand all the ins and outs of what was involved in creating that class. I don't just want somebody else coming along and messing up my beautiful reduce function, for example. Okay? I don't want somebody coming along and messing with my critical assumptions. On the other hand, I probably want to be able to extend my class to include more things. And in particular, let's say I have a point 2D, and someone comes along and says, oh, wait a minute, your point 2D class rocks. It's awesome. It's good. All right, we like it. We need a color, though. We need to give each point a color. And you say, whoa, don't touch my class, because you're going to mess something up, and I worked really hard to make sure everything was consistent and perfect. I don't want anybody touching my code. That's fine. No one's going to touch your code. Okay? What we're going to do instead is we're going to say, okay, well, we want to take all that functionality in that point2D class, and we want to extend it in a way where we're going to create a new object, say color point2D, and that color point2D object is going to have all of the same properties as a point2D object, plus some extra stuff. So question is there a way to grant a class like color point2D all of the same functionality as a point2D and then add extra stuff to it without ever needing to actually see or touch the point2D class? And the answer is yes. And that's what this is solving. Okay? So it's a really terrible Venn diagram, but the idea is you're going to have various points. Maybe instead of a color property, you want a weight. Maybe that's a double. Again, you're not going to want to copy and paste point2D class member variables and functions into this file and that file. And that. No. One location, one set of functionality, and if you improve the point2D class, all of the other classes that kind of use that are going to be updated as well. Okay? This allows you to modularize the development of the code. So let's say we wanted a point3D class, but we still wanted to take advantage of all the point2D functionality. Okay, so here's how we do it in code, and this is where we'll start out with on Friday. And here it is. You create a color point2D class that is derived from or inherits from the point2D class. Okay? So what does that mean? It means first you write class color point2D. That's nothing new. Then you write :public point2D. Okay? Now, the public point2D tells the compiler that this new class, color point2D, is derived from or inherits from the point2D class. What that means is if we create a color point2D object, then that object has the same properties as the point2D class object would have had, plus we're giving it an extra string property. Okay? So let's just end on this terminology. Point2D is referred to as the base class, and color point2D is called the inherited class. All right? There is a very subtle issue with public and private. It is more than subtle. We will start out on Friday explaining precisely what the permissions are. So think about the following. Just because you have a color point2D object that has the properties of point2D, it doesn't mean you have full access to those point2D variables. That's what we'll start discussing on Friday.